So we've got a lot of new vocabulary words for today. Up until this point, we had only been doing one equation at a time, right? Besides when we compared parallel and perpendicular lines. Okay, so we kind of touched on it a second. Did you know that those parallel and perpendicular lines made what's called a system of equations? In Spanish, it's sistema de ecuaciones. That's my bad pronunciation. Cool. So a system of equations, that's what we're going to fill in this first blank. Whoa, why is it so bold?
Oh, that was me. Sorry.
Okay. System. Oh, it's still really bold. Let me pick a bit. I don't even know what setting I use. This one's probably fine. There we go. System of equations. So system is a mathematical way to talk about more than one equation. So systems are more than one equation at the same time. Usually in Algebra 1, we're going to be dealing with systems of two equations. When you get to Algebra 2, you do 3 equations. And when you get to college, you might do 4 or 5, but that's wild, called linear algebra, whatever. Don't worry about it now. 2 equations at the same time. Make sure that these equations have the same variables. So if we have a system with A's and B's, your system needs to have A's and B's. Most of them will have X's and Y's, though, because that's what we use for equations. Now, what's important here, the new vocabulary word, is called the solution to a system of equations. We're going to be looking for that word a lot today. When we solved single equations, the solution to a single equation was a single number. Okay, so one equation was one number solution. If we're doing 2 equations at the same time, how many numbers are going to be in my solution? 2. So solutions are actually represented by an ordered pair. A coordinate point, if you will, x comma y. Because we have 2 equations, 2 letters, we're going to have 2 solutions. Well, one solution with 2 numbers in it, an ordered pair. The definition of a solution, again, is solution to a system of equations is values that make both equations in the system true. So it can't work for just one, it has to work for both. But the way that we're going to be finding these solutions today is by graphing. Now, we're not going to graph by hand. You probably realize I didn't give you any sort of ruler. We're going to be sketching by hand and graphing with technology today. We need to know the types of solutions I might be able to find. In that first column there, what does the title say? How many solutions?
2.
Wait, what?
1.
One solution. Now I have 2 equations, so it's one coordinate point. So the coordinate point has 2 numbers. The place that we find the solution is literally just where these lines cross. You see how those lines cross right there? That's at the coordinate point 3, 2. That's my solution. That was the answer choice I would pick. That's what I'd put on my quiz. Put a little box around it. We're good to go. We have one solution to the system at 3, 2, because that's where they cross. But question for you guys. What do you notice about the slopes of the lines that we're talking about here? Do we notice anything about the slopes? Are they the same?
No.
No. This is going to happen when you have different slopes. Yes. So lines that have one solution, systems that have one solution have 2 lines with different slopes. Because then at some point they have to touch. And where they touch is your solution. Does this sound familiar? We should have seen this before, right? Finding where the 2 lines cross. Okay, we're doing the same thing. I'm going to scoop back up because that was requested of me. You're good?
Yeah, it's me and you to explain it.
Oh, the solutions part?
Yeah.
So solutions is where the answer to a system of equations is called the solution. It's where the lines cross. That's all we're looking for. But since we're looking for where the lines cross, what do you notice about these parallel lines right here? Do parallel lines cross?
No.
No, parallel lines do not cross. So am I ever going to be able to find a solution to a system if the lines are parallel?
No.
No. So we call this no solution. Okay, no solution when the lines are parallel. Because like literally we're looking for where the lines cross. Parallel lines don't cross. So there's not an answer. There's no solution. What do you notice about the slopes of these lines?
There are rotations.
These up here. What do you notice about these slopes? They're both negative what? So they're the same, right? Okay, so slopes, lines that have the same slope, they probably are going to have no solution. But we're going to go a little step further here and see what we notice about the y-intercepts. What do you notice about the y-intercepts of these equations? They're different. So equations that have the same slope but a different y-intercept, they're parallel to each other, so they have no solution. Now we have one more option for this. It's called infinitely many solutions. What do you notice about, it's kind of hard to see on your paper because it's not printed in color, but if you look up at my screen, what do you notice about those two lines that are graphed there?
They're overlapped over each other.
They're overlapped over each other. Okay, so if we're finding a solution where the lines cross, where do these two lines cross here?
Everywhere.
Everywhere. Infinitely many places do they cross, so we call their solution infinitely many solutions, but that's a lot of words, so mathematicians made a shortcut. It's called IMS. You are allowed to use the shortcut. IMS. Okay, it's called infinitely many solutions, or IMS, because they perfectly overlap. Like, literally, they're the same line. In fact, what do we notice about their slopes?
That
They're the same.
Well, are they? Can you tell anything about the slope of that second line right now?
no.
No, what do we do with equations that look like that so we can talk about the slope? Solve it for y. Okay, walk me through the steps. What do I do with this first?
Subtract x.
Subtract x to the other side. It's going to cancel. We have y equal to negative x plus 2. Is y by itself? Okay. Now, if that's the case, what do we know about the slopes here? They're negative 1. So the slopes are the same. And what about the y-intercepts? They're the same. Like, literally, it's the same line, just written in two different ways. So what we notice about infinitely many solutions is that the slopes are the same, and the y-intercepts are also the same, because, like, again, literally, it's the same line. Now I'm going to show you some arm motions that we're going to go over for a second, because half of the battle of these questions is knowing what kind of solution you have. So I'm going to ask you to follow me for a second. Thanks for playing that game with me. That's a good little way to remember the 3 types of solutions you have. Let's go to the back of your notes for a second. And I want you to fill out this top part. Notice it says sketch a system. Doesn't have to be perfect. That's why we didn't get out rulers. But I want you to sketch a system just for me to check and make sure you got it with those 3 characteristics. Okay, take a second to do that. Shouldn't take us very long. Okay, so I'm seeing really good things when I walk around. Here's some examples of what I see. Oh, my pen died. I got it. Okay, for no solution, I saw a bunch of people do like this. Is that no solution? Yeah. Very cool, because these lines are what? Parallel. They go the exact same direction, so they're parallel. That means they'll never cross. That's no solution. Very good. Infinitely many solutions. Hopefully looks something like this. Doesn't matter how you draw your lines, but hopefully you have one line, and then somehow you do another line right on top of it.
Was it okay if you use arrows on that same line?
Absolutely. In fact, I really like the fact that there's arrows on there. Yeah. Or you did like on the front side where you did something like this, like where it's like right on top of it.
Yeah, that's fine.
That absolutely works. Cool. Infinitely many solutions means the lines are exactly the same. Then for one solution, how many times should that cross? Once. Doesn't matter where it crossed as long as it crossed one time. Now, as a little added bonus, I want you to take your pencil and I want you to draw a dot on the solution. Whatever you drew, I want you to draw a dot on the solution. Hopefully you drew it right where those lines cross, right?
Yeah.
I want you to put a little arrow to it. I want you to put, that's the solution. And make it happy, give it an exclamation point, and maybe a smiley face if we're really feeling it. That's what we're looking for today, and for the next 3 weeks, we're looking for that point where the 2 lines cross. Every important thing about a system of equations, well, not everything. The main important things about a system of equations happen there at that solution. Now, like I said earlier, we're not hand graphing these things. We're going to let it graph with technology and just sketch. So I'm worried about the solution, not necessarily your hands and your rulers graphing these. But what we're going to do is we have 3 examples here. We're going to graph each system of equations, sketch, and then find its solution if it exists. Okay. can I, right now, graph those 2 lines on Desmos test mode?
Yes.
Oop.
No.
What do lines have to be in? What form for them to graph? Y equals mx plus b. Okay, so here's what we're going to do. We're going to take the top equation and solve it for y. And we're going to take the bottom equation and solve it for y. Let's walk ourselves through these steps so we remember how to solve for y. What's first?
Subtract 2x.
Negative 2x on both sides. Cool, remembering all our door questions. We'd end up with positive 3y equal to negative 2x plus 6. I have 1 step left.
You're trying to get that y by itself.
I am going to get the y by itself, and I'm going to divide it by 3. Very cool. Okay, divide by 3. Divide by 3. Cool. Now, if I wasn't sure what negative 2 divided by 3 is, I would use a calculator to double check, but it's just negative 2/3. And then what is 6 divided by 3?
2.
2. Great. Okay, so I have one of them solved for y. I'm good to go. I would be able to graph this in Desmos. In fact, let's do that right now. So we're going to take this equation, and we're going to go to our Desmos test mode, and we're going to graph it. We're going to just make sure we have it in our screen, ready to roll, so that when we solve the other one, we can see where the system has a solution. So since we only have one of them in there, to be able to finish this problem, I'm going to need to solve the other one for y. This one doesn't say y equals yet, but I only have 1 step to finish it. Alex, what's the 1 step I need to do to solve this equation for y? Not minus.
Divided by.
Divided by. If I want the number in front of y to go away, I want to divide it away. Bonus question, class. What sneaky number is here in front of this?
1.
Very cool. So I'm going to write that in so you can see it. -1. Cool, cool, cool. All right, so this one, when I solve for y, it would be y equals -1 divided by 3x plus, what's 3 divided by 3?
Nothing. 0.
1 divided by, not subtracted, divided by. Cool. Once we've got that one, I want to graph it. And when I'm talking about graphing, I'm talking about graphing with technology. This would technically work in your yellow calculators as well, but I know you don't have them at home, so that's why we're using Desmos. Once you've got that solved for y, I want you to graph it as well. All right, so what are you noticing on your screen on Desmos whenever you graph it? It's a 1 solution graph. Now, you don't say 1 solution when I ask you what is the solution. I like that you said that. You actually have to tell me where the solution is. What? Okay, so let me show you what mine's going to look like on Desmos. Desmos is going to help you out. Okay, Desmos is going to help you out because it shows you how to graph it. We noticed on this one that we had a coordinate point where they crossed right here, and when we physically clicked it on our Desmos screen, it came up and told us that that was 3, 0. So that, my friends, is the solution to the system. Now, for these notes and how I want you to do these problems, when you're using a computer to graph, which is what I want you to do, I also want you to just at least sketch the graph. So I want you to, sketch it like this where it looks like they're, going through the problem. It doesn't have to be perfect, but I want you to sketch it the right way so I can see, oh, that was almost not good, that I know you know that it's where it crosses that the solution to the system is, even though you know what, I'm going to redo that because there, that's better. I need to see a sketch, which means there at least needs to be 2 lines, but I know for sure it crosses at 3, 0. How do we feel? Easy. We know how to solve for y. We know how to type. We know how to click. We can find a solution to these systems.
Yeah.
Let's make sure we know how to do that, though. Y'all got the second one over here. First things first, solve both of the equations for y. I'm going to give you a head start, but then I'll start showing you those steps on the board in case you're stuck. Yeah, that's a good thing. I'm going to write that in on here. When I'm solving these for y, there's a 1 right here. Do y'all see that? Okay, cool. Keep going. All right, so here's our solve for y versions. How'd you do? Once we have them solved for y, we're going to take both of these, and what are we going to do with these equations? We're going to graph them so we can see where the solution is. But we're graphing today with technology, So either in your calculator or with Desmos. And I want to see what happens there.
No matter how much you zoom out, it'll never cross.
So for this sketch, somebody just asked, that's a really good question. Because it's going to be off screen, just do your best. It was at negative 611, so I'm just going to put it up here. Negative 6, 11. Okay. When it's off screen, that's fine. That's why we're just sketching this anyways. But remember, we had 2 lines that look something like that. And there's our sketch. But most importantly, I still know that my solution is negative 6, 11. Bonus question here. If I was just to ask you, what's the y value of your solution? What would you answer? The y value?
11.
Oh, yeah,
11. So they can ask you, or I will ask you, for particular parts of this solution. For this one, if I said, what is the x value of your solution, what would you say?
6. Negative 6.
Negative 6. Oh, for the first one, it would be 3. You're right. But for the second one, it would be negative 6. Okay, cool. Let's do this last one together. All right? Now, which of these equations is good to go? The first one or the second one? The bottom one is already good to go. Why is the bottom one already good to go? It's already solved for y, so we're good to go. Yay, we don't have to do extra work. But we do need to solve the first one for y.
So it'd be
Let's do it step by step.
negative.
David, what's the first step here?
Subtract negative x.
Cool. I'm going to move x to the other side by subtracting, like it. Then I have 2y equal to what? What do I write down? Negative 1x
Plus 4.
plus 4. Okay, tight. Glenn, what's the last step here?
Divide 2 to all.
Divide 2 for everything so that 2 goes away. We'd have y equal negative 1/2 x plus 2. All right, sweet. This one's good to go too. Before you type anything, wait, don't type anything. Look at these 2 lines. Are they exactly the same?
They have different
Oh, the slopes are the same. So they're parallel lines. Before I do anything extra, what's the solution here?
Negative 3 and positive. Wait, solution?
Say it again,
Oh.
Lucia.
No solution.
No solution. They're parallel, which means they're not going to touch. We're going to prove to ourselves that that's true on Desmos, but we know there's no solution. So, that's when you write those words, no solution, because you can't tell me a point. But let's prove it to ourselves on Desmos. If you would please type in your 2 solved for y equations so you can see what they look like. I'll pause for a second so you can do that. Okay, for the last little bit of today before we keep going. Oh, I need to sketch my graph. What am I doing?
Just draw 2 lines.
You're not done yet?
Not for the day, but with notes we're done.
Miss, do we have?
Okay, I want to go back over the 3 types of solutions you're going to find in your systems, and then we're going to start working on our independent practice. We have 2 things for independent practice today. Okay, looking up here, how do you show me with your arms what no solution looks like? Show me with your arms. No solution.
No.
No solution.
Oh my goodness.
Yeah, parallel lines. Cool. How do you show me infinitely many solutions? You stretch your shoulders. Yeah, it looks good. Looks good. Touching elbows. Yeah. How about one solution?
That's the cross.
Okay, perfect. All right, I think we're good to go here.